This is example 5.4.1. It says a force of 100 newtons is applied by a boy on his dad. It says the boy has a mass of 20 kilograms and dad has a mass of 100 kilograms. What will the acceleration of each be? So you have dad and boy. We're going to assume that they are standing on a frictionless surface. So when the boy pushes his dad with a force of 100 newtons, Newton's third law says that there is an equal and opposite force of 100 newtons on the boy. So really what we're trying to do is we're trying to find the acceleration of dad and the acceleration of the boy. Now I put those letters there just to indicate dad and boy. They actually have no meaning in terms of the problems at all. So the things that we're going to involve here is we're going to say number one is going to be Newton's third law. For every force, for every action, okay, there's an equal and opposite reaction. It's equal and opposite. So that's why when the boy pushes his dad this way, the boy will actually go in the other direction because they're in opposite directions. So what we have here is we have number one, the force. Both the action and the reaction force have a value of 100 newtons. Now we are going to have to account for the direction, which is why it's very helpful to draw this. So now, if you have also the mass of the boy is 20 kilograms, and you have the mass of the dad being 100 kilograms. So now we can solve these each individually. We can say the sum of the forces is equal to mass times acceleration. We're going to do it for the boy, and we're going to do it for dad. So when you look at the boy, you have a force of 100 newtons that is exerted on a boy who has a mass of 20 kilograms, and you can solve for A. And in our case, the acceleration is going to be 5 meters per second squared. You can do the same thing with dad. You can say 100 newtons equals 100 A, which gives you an acceleration of 1 meter per second squared. Now you do have to be careful. Remember, the way that we originally drew this, the boy was pushing the dad to the right, which is in the positive direction. The boy, in turn, would actually have a force exerted on him to the left, or in the negative direction. So because of the way that we drew the problem, this has to be negative. Now, either one would be correct depending on how you drew it. You could have this as being negative and this as being positive, depending on how you drew it, or depending on the problem where they say to the right is positive, to the left is negative, and so forth. So you do need to be careful, but we're going to go ahead and leave it how we originally had it based on how we drew it. So you have the acceleration of the boy and the acceleration of dad. Now the reason why dad experiences less acceleration is because he is more massive. A lot of people get this confused. They say, well, wait a second, the forces are equal and opposite, so shouldn't they accelerate the same? And the answer is no. The acceleration, remember, is dependent on the mass value.